Hi, so in this video we're going to look at the modulus argument form of a complex number. So if we're given that the complex number z is equal to x as a real part plus I y, where y is the imaginary part, and that the magnitude of z we can call r for radius, we're going to show that z can be written in what's called the modulus argument form, where this r is the modulus and this theta is the argument. So if we look at this Argand diagram, you can see we've got x as a real part, where this would be the real axis, and this y would be on the imaginary axis. And the argument would be the angle from the real axis going anticlockwise to our complex number, and we'll call this theta. So from this diagram, we can work out x and y. If we take the sine of the angle theta, when this will be the opposite, which is this length y over the hypotenuse, and we're calling this magnitude r, that's given here. So it will be the opposite over the hypotenuse. So in this case, y, we can move this r to the left-hand side, so this will be r sine theta. Similarly, if we use cos of theta, well, this will be the adjacent length. So from here to here, this will be x over the hypotenuse, which we now are calling r. So now we can move the r to the left-hand side, so x will equal r cos theta. Now if we substitute these values of x and y back into our original form, we get the complex number z will be x, so r cos theta, plus the I times y, and we know y is r sine theta. And now we can factor out the radius in both terms, so the complex number will be r lots of cos theta plus I sine theta. And this is the modulus argument form of a complex number. Okay?